Okay, guys, so we're gonna do 5.3, and that's exponent laws part 1. Okay, so where we're getting at with this is the of multiplication of powers with the same base, meaning that if we had like 2 to the 4 and 2 to the 3, for multiplying, the base are the 2's, so those are the base, and the power or the exponent is that little number on top, okay, or the superscript, which is on top there. So the rule for it is if you are multiplying powers, with the same base, all you do is add the exponent. So in this case, 4 and 3, it would be 7, or 2 to the 7. That's what we're getting at with this. It says a to the m times a to the n, which would be a to the power of m plus n. Okay, so we're going to show you two different ways here, and because of this, we can come up with some different answers here. Okay, so we'll use the rule on the right side, and we'll use just straight math on the left. So in this case, if we did 2 to the power of 3, so 2 to the power of 3, we would have 8. Okay, and then 2 to the power of 2 is 4. So in this case, 8 times 4 would be 32. Okay? Now, a shortcut for this, or the rule that we just looked at, would be adding the exponents or the powers. Okay? So in this case, 2 to the power of 2 to the power of 3 times 2 to the power of 2 would just look like 2 to the power of 3 plus 2, which would be 2 to the power of 5. And if you did that on your calculator, 2 to the power of 5, you would get 32 as well. Okay? So that would be the first one. Now in this case, you'd have 10 to the power of 3, which would be 1,000. 1,000 times 10 to the power of 5, which would be 100,000. And if you multiplied those two numbers, 100,000 times 1,000, you're going to come out with 100 million. Now, for something like this, it's a lot easier if I just saw 10 to the power of 3 times 10 to the power of 5. All I know I would do is add the 3 and the 5, so it'd be 10 to the 8. And if I plug that on in my calculator, I would end up with the exact same answer. Okay? In this case. All right, we have just a couple more examples here before I let you on your way. But in this case, we've got 6 times 6 to the 3. In this case, we'd have 6, and then 6 to the power of 3 is 216. And if I multiplied that by 6, I would get 1,296. Now, if we looked at it with the rule, 6 by itself is just 6 to the power of 1. So it would be 1 plus 3, or 6 to the 4. And if I plug that into my calculator, I would end up with the same answer, 1,296. Okay. Moving to the next example, things are a little trickier because we have this, we've got this negative number right here and right here. So we're going to break it down in what that looks like. So in this case, it negative 3 to the power of 3 would be negative 3 times negative 3 times negative 3. So in this case, negative 3 times negative 3 is 9, times negative 3 is negative 27. And in this case over here, negative 3 times negative 3 is equal to positive 9. So over here, it would be negative 27 times 9. And negative 27 times 9 would be negative 243. Now you'll also realize when we have a negative number and we're doing the exponents, if this number is odd, we will end up with a negative number. If this number is even, we will end up with a positive number. And that just comes back to our integer laws that we did before. So a negative times a negative will be a positive. But if we multiplied it by another negative, it would be a positive times a negative. Therefore, it would be a negative. So in this case, it's negative 243. And if we were to do the rule with that, it would be negative 3 to the power of 5. And in this case, it would equal negative 243. Okay, so we have one more here, and we're using letters, okay, and it differs, but all the same things still apply. So if we just take our rule that we learned, m squared times m to the 8, and we just add the 2 and the 8, we would get the answer of m to the 10. Okay, so we use that rule when multiplying. Make sure when we're multiplying powers with the same base, all we do is add the exponents. Okay, so that's 5.3. Pretty short, simple lesson there, but